Hello everyone. In this video, I'm going to show you how I used KCP with Crossplane to create containers in AWS. Um, you can use different cloud provider. You can use Kubernetes. You can using on-prem. But for my example here, I'm using AWS. And the diagram, as we see here, we have Kubernetes. We have AWS account that has Fargate cluster, and of course, it has VPCs and all networks components. And also we have KCP server that is have different workspaces. One of the workspaces is used as a provider workspace that has a cluster rule, so the sync agent can access the KCP server with this cluster rule. Um, and we're using the sync agent to um, update and get sync between KCP and Kubernetes. So, um, as you see here, we have empty cluster. There is no load balancer. There is no only this shared cluster, shared Fargate cluster, but there is no tasks running or there is no services running. So let's go back to the terminal. Before we go to terminal, let's see the files um, we have here. Let's open these files and see. Um, the idea is we want to give the consumer in the KCP a CRD or an API that they can use a YAML file by using KRM to apply this YAML file. So the just say, okay, the app name and the Docker image and port. It can be different between consumers, and each one can have their own image or own port, right? So we have different examples here. And also the sync agent workspace, what I say is um, when you deploy sync agent, you need to have a secret. And this secret, you get it from the KCP server. Um, and then this RPAC, because you need to have access. And this is published resources. This is the needed for sync agent, and this API export that is needed in the KCP workspace provider. And we name it provider. It can be any name, but to make it simple and easy, uh, we used this provider that has API export, and the another ones we name it consumers, and inside there we have different companies. As an example, each one has API binding there. So let's see what we have here. So starting from the um, let's say here, let's see from here. Okay, if you want to use Crossplane, you can have a different YAML files with the security group and how to create the cluster as a YAML file, right? And with the service and all this stuff. But there is another way to do this using composition. So in the composition part, we can have um, first this function, and then this creation of the cluster, and the composition. We can have all the pipeline that we want to create. For example, security group, um, load balancer, listener and load balancer, the application load balancer, and then target group, and then task definition, and the ECS service. And you have this XRD, which means the template. It's like template for the claim. So what we can use is, as you see here, we have DNS name. We're gonna see in the Kubernetes why we need this DNS name, because once the consumer create a cluster or create not a, yeah a container, then he can see the DNS of the load balancer. So let's see. Here I have a provider cluster, the provider workspace. This is a KCP, and here the Kubernetes cluster. I have I'm using Kind in my local PC, and also, as you see, we have Crossplane provider from EC2, ECS, and also load balancer. And as you see here, the sync agent is running. This sync agent is sync with the KCP provider workspace. And you need to use a different kubeconfig file to access the KCP. And then this is um, the workspace we have for a provider. As you see, I have cluster rule binding that I use for sync agent, and you need to have API export. So in consumer part, if we have the consumer that have different consumers, as you see, company one, company two, whatever number of consumers, each consumer or each workspace has the APIs. So let's see what we are now. Um, we are in org, so let's see consumers and company one. Okay, the switch in the consumer. Let's see where I am stopping. So I'm in the company one. So again, if I do kubectl get ECS apps, or let's see the API resources. So this is the Kubernetes API in this workspace. As you see here, we have ECS apps. This is the one is um, used or created. And then if we have any CRDs, if we have any YAML files, or if we have creating a new container or new application, we will use this resource, ECS apps. So let's do kubectl apply -f example.yaml, and if we do like this, then the resource is created. We can see get ECS apps. Okay, it takes a little bit time, but if I go to the provider, Kubernetes provider, and I will do kubectl get ECS apps as well, you start see 25 seconds ago is created. And if I do kubectl get managed, then we will see a new Crossplane is starting to create it using composition and starting to creating different resources, task definition, load balancer, and services. I already created the cluster ECS in the beginning, but I don't need to for each container, because right now I want to expose a container as a service. So each consumer or any consumer can use his own container, right? As you see here, until now, DNS name, there is no DNS name yet, but after everything is created, then we can see um, DNS name, then we can use it. It will take a little bit time, so we can go to another workspace and um, I'll switch to another workspace, and then I need to do like this. I'm not sure this is right. Oh, okay. Then if I do kubectl get ECS apps, I don't create anything in this workspace. I'm also have Kubernetes APIs, my own Kubernetes APIs in this workspace as isolated from other ones. So I also have ECS apps here. So I can also build another application. So if I do example 2.yaml, oh, so I want to use this Matumo app, right? So I will apply this app, this YAML, and then after that, we will see get ECS apps, and it still take time. As you see, it's a different name. If we go back to the providers, we will see a new resources showed, and also 16 seconds ago. And also, if we see the ECS apps, we still it's still building. Yeah. If I go to AWS account and I refresh, I will see load balancer start to provision. And if I go to services or task, I will see different task is created. And then inside the cluster, stuff still not created yet, but we will, it will take a little bit time. Let's go to the last um, workspace and we will create another. So we do get example 3, yeah. And here, as an example, I want to use container image, PHP admin. So as you see here, I'm using KRM, Kubernetes Resource Model, not normal like REST API. No, I'm using Kubernetes API. And then we can um, expose, or as a provider, I can expose container as a service. So this one is created. Let's see. Um, get ECS apps seconds ago, and then let's go to Kubernetes and see. Okay, the first one is already done, and you see the nest name. We will go on this one, and let's see the managed stuff, if it's true or not. Uh, the resources created. Okay, the first one, load balancer, is created true. As you see, it's ready, and listener is ready, task definition is ready, service is ready for the first workspace. And yeah, right now what we can do is we can use the DNS, but before we do this, let's go back to the first workspace and then see if we can see the DNS. Yes, we can see the DNS and sync true and ready true. If we take this DNS and go, oh, not here. So it takes a little bit of time as a service. Okay. And let's do this. Okay. It's Docker. Um, this is the image we use it. So let's go to the second. Okay, let's see here. Get managed if everything is true. Takes a little bit of time. Okay, second one is ready. So if we go to the second company or the second workspace and we go to Git apps, still not yet finished. Okay, it takes a little bit of time. Let's see the company 3 and Git apps. Okay, it's true, but still didn't get the DNS. Oh, not ready yet. Okay, let's go to. Okay, it takes a little bit of time, but the idea is each consumer or each workspace has its own isolated Kubernetes API, and then you can create in this Kubernetes workspace a new resources by consuming the CRDs, and then is be used. The sync agent will create the same resources from this workspace to the provider. to the provider Kubernetes CRDs. So here you can see all CRDs in the provider that is used. As I'm doing here with managed and also doing with the ECS app. So if I do Kubernetes API resources, grep ECS apps, you see also here. Let's see if we can get the managed. Is everything true? Okay, the last one is still not finished, but let's see if the first one um, is done. Oh, DNS is done. Okay, take this URL and go to the browser and open. Okay, it takes a little bit time. Let's see here. It's pending. Last is pending. It should be running. And let's see the services. Okay. And tasks. Okay. The load balancer. As you see, 3 is created. Okay. And here, let's refresh again. Take a little time. Okay. Matumo is ready as the application. So let's see the third one. And get apps. Okay, PHP admin. Still is here is not ready, but it will take a little bit time and then it will be ready. So the idea here also you can get the DNS name by a status of the load balancer that is returned back to the workspace, right? You also can return to the config map. For example, here you can see the config map and secrets. Here you can see config maps, you can see secrets. So you can also um, write these values inside the provider, and it's by sync agent, it will return back to your workspace. So let's see the last PHP admin. How long? Okay, so again, it take a little time, but let's see the tasks. Okay, it's running, PHP admin, and it should be running. Take a little time. Let's see in the cluster here. Let's see apps. Okay, true. Created 5 minutes ago. And okay, it works. So what we have done here is we can exposing any service, X as a service, database as a service, Kafka as a service, object storage as a service, anything you want to expose as a service through KCP, and KCP will let you have multi-tenant. Each tenant has his own isolated workspace, isolated Kubernetes API. Yes. Thank you very much and have a nice day.